Hi, my name is Vijay Kumar. Today I am explaining S Bank stock closing price prediction. It is a regression algorithm project. It is my individual contribution. Problem statement. S Bank is a well-known bank in Indian financial domain. Since 2018, it has been in the news because of fraud case involving Rana Kapoor. Owing to this fact, it is interesting to see how that impacted the stock prices of the company and whether time series models or any other predictive models can do justice to such situations. We started it as monthly stock prices of the bank since its inception and includes closing starting highest and lowest stock prices of every month. The main objective is to predict stock's closing price of the month. We are given as bank's stock data. In the stock data, we have opening stock price and closing stock price and highest and lowest prices of the stock. So now let's go. What is stock? Stock is the financial instrument that represents ownership in a company. It is just a unit of ownership in a company. Trying to know our data because if we know our data, we can implement good models. So now what we do is first we have to look at the data and then we'll go with the flow. In this project, we do PHR engineering means introducing some new variables or dummy variables, univariate analysis. It is disk plot or histogram or bar plot analysis, bivariate analysis, box plot or heat map. Uh, in this project, we implemented linear regression also and rigid, elastic net and XGBoost regression. General guidelines. These are the general guidelines. Now let's look into the project. We'll implement all these libraries. We'll mount our drive. This is our path. Dataset.head, and this gives the overview of our dataset. We have five columns: date, open, high, low, close. And then we look at dataset.tail. It gives last five rows of the dataset. So first our data we have data from July 2005 to and November 20 November 2020. We use dataset dot display so we can get all count, mean, standard deviation, minimum, 25 percentile, maximum values. So these are the description of our data, and we'll see uh, object data types of our PHS. Date date column is object data type. Open, high, low, and close other independent variables are stored. It's good. Now we'll change. So we have to change date object data type into date time data type. So here using list we'll get columns. We using shift we have 185 rows and 5 columns. We have 185 rows and 5 columns. Our dependent variable is closing stock price and independent variables are open, high, and low. Date denotes month and year for a particular price. Open means price at which a stock started during trading that month. High refers to maximum price in that month. Low refers to minimum price in that month. Close refers to final trading price for that month, which we have to predict using regression. These are the simple terms. Now we'll do data cleaning. First, we have to know what are the null values in our data set. By using this function, we'll get to know how many null values we have. Fortunately, we don't have any null values in our data set. Now we have to see duplicates. We don't have any duplicates in our data. Now what we do is we'll change our date. We'll change our date column to date time data type. Using this function, we'll change it to date time data type. Now here we can clearly see date column is modified into datetime data type. Checking outliers, we'll use this box plot to check any other outliers. For open, we have this box plot. High, we have this one. Low and close, we have this one. Now, now we'll do exploratory data analysis, visualizing the data. Now, what we do is here we plot date, data set date and close. We plot date column and closing the close PHL. So it is simply a date versus close. These are the title as bank closing price. Here we can see years and it is closing prices. So as the year we moves, the close from 2000 from 2006 to 2018, the start price increased, but from 2018 to 2020, the start price decreased. It is due to Rana Kapoor case, fraud case. Closing price of stock price is always important. So I take so we take closing price as dependent variable of close price of stock. Now what we are doing is we'll do univariate analysis of close PHF. So in order to do it, we'll just use this plot function. We'll get here the graph using these comments. So here this closing price is rightly skewed. So we'll make it normal distribution using log transformation. Now here we'll just simply use np.log10 dataset.close. We are log transforming the closed PHL. So now we get normal distribution. We'll do same with the independent variables open, high, and low price. Same univariate analysis and log transform. While doing open, while doing an univariate analysis of open PHL, we see it's rightly skewed. So I'm just making it normal with log transformation. Same case with the high, it's also right skewed. So we are using log, same here low. So we are making it normal by log transformation. So now what we do is we scatter, close and open. We'll do use scatter to check. We are using here bivariate analysis. We are comparing open and closing prices of the stock. So we by using this code, we will get this graph. It is linearly correlated. These two variables. Now we'll do with high. It's also linearly correlated, highly correlated. These two graphs are highly correlated. Now with low, it's also same. Now we'll check correlation in our data set. Now here we are Using this heat map, we will see correlation between our independent and dependent variables. We can see very it is in this data. We can see all features or R variables are very highly correlated. Now, now we'll check VFX of our features. Using this code, we'll get VFX of open and high and low. Now, we can see VFX is very high. So what we are doing, we can't remove all these variables. We just simply remove open and open feature. So now I'm checking here VF of VIF of high and open using this code. Now here we'll see high, low and close. We have removed open feature due to its very high VIF. So this is the our linear. This is our correlation between dependent and independent features. We have dropped three features from our dataset. It can affect our model efficiency, but neglecting high VIF is far more dangerous than dropping features. So we prefer to drop features and move forward with low variable. Now our data cleaning and exploratory data analysis over. Now we'll do train split, train test split. Here x is independent variable and y is dependent variable. Here we'll see dataset of drop column close and date. Here close is a dependent variable. Date we don't have anything to do with date here. So we are removing these two columns from the dataset. And y is dependent variable is closing price of the stock. Now we'll do their data transformation. We apply z-score and log transformation to dependent variable. Now we are splitting the data set into training and testing set. Using this code, we'll do it. Print extend shape. Here we use 0.2 as test size. So 80% is training data set, 20% is testing data set. We are we are standardizing the extend and xtest. So this is our process for train split data. Now we use five models here. These five models in linear regression. Here it's very simple. We need to use linear regression model here and fitting x train and y train wrong. And here we find accuracy of this model, which is 0.847. It is accuracy for x train and it is accuracy for training dataset. It is for testing dataset. Both are very similar. It's fine. Now we predict the predict for testing dataset using this code regressor dot predict dot x test. We'll get prediction for x test. That means we are predicting dependent variable for testing dataset. So we get it here. We get this one. Now we are making this by test into arrays. Now we are creating data frame of test and train dataset. Now we are test dataset predicted closing price equal to y price. test data set head, we'll get this one. Here we are getting metrics for linear regression. These are the metrics, and we plot here. This is our scatter plot. Now here we plot using these values. We plot actual and predicted. So this is our plot. Now we are implementing region lasso. Here lasso will import lasso, and we are checking accuracy. Accuracy is this is for training, and this is for testing. These are the predicted dependent variable. Same here also we will check metrics and we'll plot here. Implementing we implement cross validation for one also. Cross validation is we it's very simple. We divide the data set into three or five data sets, and first we'll do five times of what we say. First we'll divide here we have take CV equal to 3. We'll do test split three times, taking first us- taking samples for three times. It is 5 means we'll do for five times. Whatever out of these three, whichever is best, we'll take that one. So here we'll take best score. So using this, we got it here. Here we got predicted values. These are predicted values. Here we'll get metrics. These are scatter plot and plot plot crops. Implementing Ridge, which also it's also very same like Lasso, but here we use L2 penalty. So we are implementing here. These are scores for testing and training and testing. These are metrics, scatter plot, and plotting graphs. Here also we implement the cross validation. Using cross validation, we get here these values. It's very simple. Just write just writing code and implementing libraries and fitting extend and x test. These are our metrics. We plot them. Now we'll do elastic net. Elastic net is the combination of reach and loss. Here we take alpha 0.1. L1 ratio is 0.005. Here we are fitting X test, X train and Y train. These are the accuracy scores for X train and Y train. Here, this is predicted dependent variable that is Y predictions. These are metric, these are scatter plot. We plot them. Here we can see actual and predicted. This is actual and this is predicted. Now we implement cross validation for elastic net. It is also same like region also. By implementing here, we get these metrics, these these scatter plots. Now here we implement XGBoost regressor. XGBoost regressor stands for extreme gradient boosting. It is a optimized distributed gradient boosting library designed to highly efficient and flexible portable. XGBoost regressor is for continuous numerical output. So we have close is continuous numerical. So we are using XGBoost regressor after implementing these libraries. So we get score for a training data set is 0.99. and here we get predicted values. These are our metrics. This is our scatter plot. So out of uh, these five models, XGBoost, XGBoost regressor, we got very good metrics. So it's better to consider it as the best model for this problem. By conclusion, the popularity of stock price is growing extremely rapidly day by day, which encourages researchers to find new method if any problem happens. As we can see here from this point, stock prices is increasing very rapidly. So there need to be a vigilant focus here. Here we techniques we used not only helpful for to predict future price or closing price or fraud happens, but also if any investor wants to know the future price, this model is very helpful. In this work, we use linear regression, lasso, redshift, elastic, and XGBoost. Out of these five models give the following register: high, low, and open are directly correlated with closing price of stocks. Target variable dependent and dependent variable strongly dependent on independent variable, as we can see in heat map. And XGBoost regression is best model for S bank closing price. The closing price. This model is so out of these five models, XGBoost regression is the best model for this problem. This is this is our project. Thank you.